For more than a century, cars ruled the ground and airplanes ruled the sky. But today, those two worlds collide. This is not science fiction, and it is not a concept. This is a real factory where flying cars are being designed, built, tested, and prepared for the future of mobility. A flying car lifts vertically from a city rooftop at sunrise as robotic arms move in slow motion, sparks fly, and carbon fiber sheets are shaped with precision. A flying car is a hybrid machine, part automobile and part aircraft, engineered to meet road safety standards, aviation regulations, and extreme performance demands all at once. Every component is built for lightweight strength, precision, and redundancy, beginning long before the first physical part exists. Engineers first create the vehicle digitally, simulating airflow, stress, vibration, heat, and emergency scenarios until every bolt, wire, and rotor blade survives extreme virtual testing. Inside the factory, aerospace-grade materials like carbon fiber composites, aluminum lithium alloys, and titanium are carefully prepared, chosen to be lighter than steel, yet stronger under stress, cut with tolerances finer than a human hair. Robotic systems assemble the chassis, the backbone of the flying car, designed to endure both potholes on the road and turbulence in the sky, verified continuously by laser alignment systems. Electric propulsion systems are then built and balanced using high-efficiency VTOL motors and rotor blades designed with redundancy so that flight remains stable even if one unit fails. Advanced battery packs with intelligent energy management systems power the vehicle, monitoring temperature, voltage, and charge thousands of times per second. Artificial intelligence and flight control systems integrate LiDAR, radar, GPS, and vision sensors, allowing the flying car to stabilize, navigate, and avoid obstacles through millions of simulated flight hours. Inside the cockpit, safety and comfort merge through aviation-grade harnesses, energy-absorbing seats, and emergency systems. As final assembly brings every system together, teams inspect each connection with absolute precision. Before flight, the vehicle endures brutal ground tests, vibration trials, and wind resistance simulations. Initial flights are cautious, tethered, and controlled, while engineers analyze massive streams of data in real time. Certification follows, demanding approval from both road and aviation authorities, one of the most complex processes in transportation history. And finally, as the flying car rises into the sunset skyline, it becomes clear. This factory is not just building vehicles, it is redefining how humanity moves. The road and the sky are no longer separate. The age of flying cars has begun.
Check the pressure readings here.
Okay, they're nominal. What's next? I'm seeing a spike on this sensor.
Good catch. Let's recalibrate it.
The new active aero elements are performing exceptionally well.
Impressive. And the stability at high speeds?
It's rock solid. We can proceed. The thrust vectoring is integrated here.
Impressive. And the cooling?
It's all handled internally. There it is, perfect bank. Engine output is optimal. Look at that speed, bringing it back around.